Hi everyone, welcome to my poster session presentation titled Using the 3-Minute All-Out Running Test to Examine Exercise Science Students. I'm Carly Fornchell. I'm a senior graduating in May with my degree in exercise science, and I hope to become a physical therapist. I'm also on the cross-country and track and field teams at Concordia, and so this research really aligns with some of my passions and interests in life. And I did this research with Dr. Nathan Dix from the Exercise Science Department. And so just a little background context into this research. I began doing background research in the summer with hopes to complete it and do a little bit more with it in the fall through a practicum of mine. But with COVID and other extenuating circumstances, I didn't get to do that, but I was able to conduct the research and the test with exercise science students. And so I was really happy to get the data I have to analyze. And so with that, we'll jump right into it. Exercise science students explore the importance and the differences of different exercise tests and prescriptions, and then their benefits to active populations. And so the 3-minute all-out test, or the 3MT, is one of these tests that can be used to examine an individual's critical speed and D prime. And so critical speed is the maximum speed that an athlete can run while consuming adequate oxygen to continue exercising and running at that same intensity. And so D prime, on the other hand, is the short-term ability to exceed critical speed. And so with D prime, it's the distance you can run before you've expended all of your anaerobic energy stores. And once those energy stores are gone, you have to revert to using oxygen and consuming it enough to continue exercise. And so the purpose of this study was to determine how critical speed and D prime compare amongst different athletes and individuals in the exercise science department. And so I was able to recruit 7 exercise science students. 5 of them are female and 2 are male to complete the 3MT on an indoor 200-meter track. So if we go up to figure 1, we can see the 300 or the 200-meter track on the very right, and then participants were fitted with a watch on their wrist and a foot pod which went on their shoe. And so the foot pod collected data as they were running and then transferred it to the watch for us to analyze later. And so participants completed an active 10-minute warm-up, and when they felt ready to go, I commanded go. And on the command, they accelerated to their maximal speed and then maintained this throughout the duration of the 3-minute test. And so they slowed down throughout the test, but they were always encouraged to run as hard as they could for the duration of the test. And if a student or a participant paces this test, the results will be not as accurate, and so they were deterred from pacing, and we also didn't give them elapsed time or the time they had left so that they didn't know where they were in the test. And so critical speed was then calculated as the mean speed during the last 30 seconds of the 3MT. So if we go over to figure 2 in the middle, you can see that in the last 30 seconds of those graphs, each individual runner kind of plateaus in those last 30 seconds. And so the mean speed within that is what is used to calculate critical speed. And then D prime is calculated by an equation, and that equation looks at the first 150 seconds of the graph. And so if you see, that's when they accelerate to their max speed, and then they have that steady decline until they reach that critical speed. And so for statistical analysis and results, the groups were split into 2 groups originally. So the first group were track athletes, and then the second group was non-track athletes. And for this comparison, we used an independent t-test and statistical significance of a p-value of 0.05. And so if we move down to figure 3 now, we can see the differences between these 2 groups. And so the ones in gold bars are the track athletes, and the one in maroon are the non-track athletes. And so graph figure 3A shows critical speed results, and there was a statistical difference between track athletes and non-track athletes for critical speed, but not for D prime. And so that just means that track athletes had a significantly higher critical speed than non-track athletes. And then secondary analysis was also done between 4 different groups. And so the individuals were split into field athletes, non-athletes, distance athletes, and mid-distance athletes. And figure 3 also compares each one of them, each group between each other. And so if we look at figure 3A for critical speed, we see that distance athletes had the highest critical speed, which isn't surprising because of what their events are in the longer distance range. But these distance athletes also had almost the lowest D prime. And so if we look at figure 3B, that specifically looks at D prime, we see that mid-distance athletes have the highest D prime, which isn't surprising either because they need to use their anaerobic energy capacities to do events like the 400 and the 800. And then if we go back to figure 2, we can also see the difference between the athletes and how they ran for that 4 different group comparison. And so the mid-distance athlete is illustrated in maroon, and so they accelerated to a higher speed than any of the other groups, and then declined at a pretty linear rate until they reached that critical speed. The distance runner is illustrated in yellow, and so this athlete again accelerates to their maximal speed, but then very quickly levels out to around that critical speed level. And then the non-runner, the non-athlete, is in white, and so this participant accelerated to their max speed and then very quickly fell off of that speed and leveled out into their critical speed. You can see that comparison there. And then for the results, we just did some averages between all 7 participants. The FootPod collected a lot of data that gave us averages, including critical speed, D prime, their maximal speed, their velocity at VO2 max, and then their maximum distance that they covered throughout the 3 minutes. And so that's what Table 1 is illustrating as well. So in conclusion, the 3MT can be used to create profiles for different types of athletes and non-athletes. And so it would first be used as an assessment to assess fitness and training status of an individual. And then from there, it could be used to prescribe individual interval training sessions. And then these interval sessions are specific to the individual so that they can receive maximum benefits of cardiorespiratory fitness training. And then you could retest them again to see their improvement as they run those intervals. So to wrap up, I would just like to say a few thank yous. I would like to thank all the participants who completed the 3MT and let me use their data. I would also like to thank the Exercise Science Department for letting me use their equipment and their space and their time. And then finally, the track and field coaches, Laura, Marv, and Garrick, for letting me use a few of their athletes who are also in the Exercise Science Department. And so with that, I thank you for watching this poster presentation, and I encourage you to join on April 14th for the live Q&A. Thanks.